Yeah.
He doesn't do math anymore.
He got the.
Oh, he's gone.
Yeah.
Hey,
He's not doing math.
means gone.
No, no, he's got the. He's got the.
He dropped math.
Just maths.
Yeah.
He's still in his other classes?
Yes.
Yeah.
Sometimes? All the time?
Okay.
Oh, okay, good.
Because they like me.
Okay.
Attendance is dangerous.
Yeah.
Huh?
Attendance is dangerous.
Yes. Well, you need 80% for visa?
Yes.
Yeah, yeah. Okay. First. Okay. Now, this word, binomial. It's actually useful to look at this word before we start. This part here, the bi, what does that mean in English if a word begins with bi? B-I. Think about words that begin with bi, like bicycle.
Two.
It means two. Yeah? So this part here means two. So with binomial, it means two outcomes. I'll give you an example. You have a person and they can vote yes or they can vote no. Or you have a coin and it can be heads or it could be tails. Okay? Or you have the weather. It could rain or not rain. So for binomial, you're always looking at problems that have two outcomes. Do you understand the word?
Yeah.
Yeah? Okay, that's good. That's good. Okay, so let me give you an example. Suppose you have something like 5 people. 1, 2, 3, 4, 5. And let's say they each want to vote. So they can vote yes or no. And we think a person maybe will vote yes 60% and vote no 40% of the time. So my question might be, what's the probability that 3 people vote yes? And what's important about binomial is the order is not important. So what I mean is, yes, 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 no, no is the same as yes, no, yes, no, yes. That the order is not important. Okay, so do we have the idea so far? Yeah? So there is a way to calculate this. First, you have to say what the P is. So each one of these people, it's 60%. And the Q means no, and that is 40%. Okay. The N is how many people we have, which is 5, and the X is how many vote yes, 3. And there's a formula to calculate the probability, and the formula is NCX PX Q N minus X. Now, this formula is in the formula book. So in this example, it would be 5C3 0.6 power 3 0.4 power what? What's the last power here? 2. Yeah. Yeah. Now you have your calculator, and
I'm trying to get on my laptop.
okay. Could you practice typing this in on your calculator? You have a science calculator on this. Can I see? Yeah. Right. So. Can we get more functions?
No.
This is everything?
Yeah.
It doesn't have this one. So you can see here on his calculator, look, he has NCR. You don't have this?
No, my calculator is.
Oh yeah, but this
This
doesn't have this.
Yeah.
Okay. Can you practice typing that in? Oh good, you can at least get... Wait, what number is that? What number did you write down?
This one?
Yeah.
12 pounds 93.
No, impossible.
What?
It must be that... No. What did you type? You made a mistake. Try again.
Is that right?
That is true, yeah. But you have the end. You have this button on the calculator. Look.
Okay. I just the right.
Oh yeah, you're just checking. But see. Oh, it's useful. No, Tom, calculate again. That shouldn't be 12. How did you get that? Check.
What is this?
0.6.
Yeah. Now I recommend you use brackets. Brackets.
0.6. Ah.
Here we go.
I'm sorry. I messed with the not no.
That is okay. Here. You want the 5C3, is it?
Yeah.
Yeah. Do you have a calculator working, Anthony?
Yes, sir.
Yeah. Can you type in 5C3 to tell Tom what that is?
10.
10. Yeah? What?
31.
Yeah, but this part here is 10. Yeah. You got, what's the final answer? 0.34. Now, I think it's okay, but I think the brackets are helpful just to make sure it's okay. Just to be safe, you know? Yeah. Okay. So this is 0.34. Yeah? Now we'll do harder ones in a moment, but I'll just give you one more easy one to try. Can I scroll down? So let's see. Let's say I don't know. You're making phones. And let's say the probability that the phone is broken is, let's say it's a cheap phone, let's say it's 0.1.
Nokia.
A Nokia, yes. And the Q is 0.9, and this is the probability the phone is broken. Okay? And you have a box of, let's say, 20 phones. Well, maybe these are phones that are used, you know, from a second-hand shop, you know.
Oh, okay.
Yeah, so you have 20 phones, and you want to know what's the probability that 3 of them are broken. And just so I can help you, Tom, 20 C3 is 1140. Yeah. Well, 1140. You have an answer?
Yeah.
What? Can I see what you got? Oops. Yes, looks good. We'll see if Tom gets the same answer.
I don't know.
No, believe Tom. What did you guess, Anthony?
1.9.
Probability should be less than 1 always. What's wrong, Tom?
0.9.
Yeah.
7.
But you can do that on your calculator, no?
I need more 17 times.
No. You should have a button for this. 0.9 power, that button, 17. There you go.
I'm stupid.
No, don't say that, Tom. You were going to multiply 17 times. Yeah.
So I used the 3 or 4 numbers.
4.
4 numbers.
Yeah. So I'll just type it in here so you can check. So you had 20. You had this?
Yeah.
Okay, and then you had, whoops, this, yeah? And then you had 17. Yeah.
Yeah.
What?
Yeah, it's right.
Sure. What's wrong? It's right.
Because it is here is.
Oh yeah, because I didn't round to 4. But that's fine, because in the exam you just write 0.190 in the exam. 0.190. Okay, let's do a harder one now. Harder, this is easy for babies, okay, so let's do a harder one now. So, let's say again, we're back to our 5 people. We have 5 people, and the probability that, let's say, what would we say? I would just say they vote yes, is 0.75. And this is that they vote yes. Okay, this time I want the probability that 0 or 1 votes yes. Now that's a little bit different. Yeah, why is that different to the last example we did?
Because we now have 2.
That's it. We have 2. Because last time I just asked you for 3 people. This time I want 0 or 1. So what do we do when we have 2 numbers? Calculate the 2 answers and what's next? What do you do with the 2 answers?
Use or 2
What do you do with the 2 answers?
You add them.
You add them. So you get the first answer, you get the second answer, and you add them because OR means add. Is it okay? Can you calculate and see?
So Q is 0.25.
Yep. Good. Yeah. Oh, which one do you want me to calculate?
I just want 5C0 is 1.
5C0 is 1, correct, and the other one is 5C1 is 5.
should I see?
5. You having trouble? No, you're got, that's small, small. That's 0.0009. Yeah. Nearly 0.
So
No, just so small. That's the final answer?
no.
Okay. Anthony, you have an answer?
Immigration, driven.
Yeah. And Tom, you have an answer?
Not too sure.
But you have an answer?
Yeah.
What did you get?
0.63.
Seems pretty big. I thought it should be pretty small.
Is it small?
Hmm. This is what I got, Tom. Look, that's what I got.
Oh.
What happened?
Um,
This is your first answer?
yeah.
This looks good. This is your second answer?
Yeah.
This looks bad.
Yeah.
No,
I
second
just
is
did a mistake. Because 0.7 when I get the wrong answer.
Oh. Wait, this is for 1. Oh, yeah. 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 That's wrong, yeah. That's my final answer. It's okay?
Yeah.
Right, let's make it harder again. Okay. Can I scroll down?
Yeah.
Okay, so we have a coin, and it can be heads or tails. And of course the probability is 0.5. Okay? And let's say I flip the coin 10 times. You understand? 10 times. 10 times. And I want the probability of 2 or more heads. Now, what do we do here? 2 or more.
2 or
No, more than that.
It's 1 minus 2 or less.
Yeah, that's it, yeah. You see, 2 or more, and we'll get to that in a moment. 2 or more means 2 or 3 or 4, all the way up to 10. Now that will take a long time to do, won't it? Because you have to do 2, 3, 4, 5, 6, 7, 8, 9, 10. But you spot if there's actually a shortcut, there's a trick here. You can say this is equal to 1 minus 0 or 1. Yeah?
no.
Watch. What's the let's say the probability that you're happy is 0.7. Then the probability of not happy, it has to be 0.3. Because the total
1.
has to be 1. So, you have to get 0, or 1, or 2, all the way up to 10. That has to equal 1. It has to, because that's everything. You could get 0 heads, 1 head, 2 heads. So this is everything. So if I want 2 to 10, that's equal to 1 minus 0 or 1. Yeah?
Okay.
Is it okay?
Yeah, I can.
You get this, are you sure?
Yeah.
So here,
If they say like 4 or more, it would then be 1 equals the probability of 1, 2, 3, 4.
yeah, if it said 4 or more, then it'd be 1 minus 0, 1, 2, 3.
Yeah.
Okay, yeah.
Because you said 4 or more.
Yeah, so the 0, 1, 2, 3.
Yeah, because the 4 is on the other one, yeah.
So my question is for the column y average, the total y is not 10 is what?
Here,
Yeah. No.
here,
Yeah, y is 1 minus 0 or 1, not 10 minus.
because this here is a probability, and the probability must be 1.
Oh, okay.
Yeah. You're thinking it should be here, you're thinking this should be 10, was it?
Yeah.
Yeah, but it's a probability. The total is 100%, which is 1.
Okay.
Yeah. Is okay?
Yeah.
Are you sure?
I'm sure.
Okay, good. So can you calculate this? Let's see what you get. So 1 minus, okay, calculate. Yeah. Have you done this before?
Yeah.
Yeah. So it's not too hard.
And not hard.
Yeah.
Not this page.
That's different, I think. Oh no, that's kind of the same. Like here, 2 or fewer rejected. That's 0, 1, 2. That's like what we're doing today. Yeah?
Not this. Can I just double this?
Yes, you can. Yeah. You want to do it all in one.
Yeah.
Yeah.
That's
Good. What did you get?
0.9.
And did you include the 1? That's your final answer.
Yeah.
Yeah. Let's see. So 1 minus. Okay, what's the first one? It's 10 C 0. 0.5 power 0. 0.5 power 10. Whoa. Plus 10 C1. 0.5 power 1. 0.5 power 9.
Yeah.
989.
989.
0.989.
Yeah.
Yeah?
But
That's right.
okay. Why
What?
friendly number?
No, don't worry. Only 3 need to be right.
Oh, okay.
Yeah. Yeah. My calculator is better than your calculator.
Yeah.
Yes.
Okay.
Okay. We'll do one more of these. and then we can do something else if you like. But this last one is the hardest one. Imagine what will we make it again? We'll make it, what will we make it? People, and they can like coffee or no coffee. And we'll say the probability is 0.6 for coffee, and no coffee, of course, is 0.4. And we'll say that we have 10 people. Yeah? Right, here is the hardest one. You'll have to think about this one. I want the probability that at least one person likes coffee. And it's important, at least one person likes coffee. Now, have a think about that. What do we need to calculate?
So the probability of liking coffee is 0.6, right?
Mm-hmm. If I say at least one, yeah.
0 minus
1 minus 0. Yeah. How did you get that? Like, what does it mean to say at least one? How many people is at least one?
1. 1 or less.
One or,
Less.
no, the other way?
More.
More, yeah.
Yeah.
At least one means one or more. So this is one or more, which of course is 1 plus 2 all the way, in this example, to 10. But that's equal to 1 minus, that's it, probability of 0. Good. Now you have to, they like this in the exam, this at least one or, 2 or more. It's very common in the exam. So you need to be careful with your English here. Okay. Can you calculate this? Do you understand it, Tom?
Yeah.
Yeah? Okay.
I don't like it.
No, it's great. It's a little English. Huh? No. What number did you get?
Not good.
Oh, that's 0.
0, 0, 0. But not the sum.
Oh, not the final.
Yeah.
Okay.
So 0.999.
Could be. It should be a big number. Should be big. Because think about it. If you have 10 people and each one is 60% chance of liking coffee, in a group of 10 people, how many do you think should usually like coffee? About 6 people. Yeah, because if you're 60% and you have 10, then about 6 people should like coffee. So it seems very likely at least one person likes coffee. Seems very likely. So let's calculate it. 1 minus, what is it, 10, see 0, 0.6 power 0, and 0.4 power 10. Yeah, 999.8. So if I was to round it, it would actually be 1.00 to 3 significant figures. Yeah, so it's nearly guaranteed at least one person would like coffee.
So it's under nearest one. They need less than 1 to
Yeah, if it's 0.9995, then it becomes 1.
So the red one.
Yeah.
Okay.
So in this situation, we should write 1.
technically for the exam you should, because the exam requires students to give their answer to 3 significant figures. So 3 significant figures is this. So the 5 means you have to go up, you know.
Is the 5 change 4?
Then it's 999.
Okay.
Yeah. Okay, this one's okay?
Mm-hmm.
Yeah. So you wanted some questions on binomial. Is the binomial okay now?
Yeah.
Yeah. Did you have something else you wanted to see? That's okay. We can go back to the algebra.
Maybe this. Market.
This one. This one will take a bit of time. We can do this one next week.
Okay.
Okay. But actually, maybe what we'll do to finish is let's have a look at an exam question on binomial. Let's see what they ask you to do in the exam. I think in the exam it's a good question. It's not too difficult.
How many marks would this be?
Well, it depends. If it's in section B, it could be like maybe 10 marks. Section A could be like maybe 3 marks, you know. Let's have a look. Do I have, let me think. Yeah, sorry. Business. Maths. Huh? What the heck? Okay, that's strange, sorry. Maths. Let's see, if I got 2015 business, no I don't. Maybe I have 2014. 2014 business, there we go. Final exam. Your exam will be a little bit different to this, but the question should be similar. Difficulty, or let's see. Here's a good one. This question is 4 marks. It's like 4 in 5 adults have a mobile phone. It's probably more than this. It's probably like, what would you say, 9 in 10 adults have a mobile phone?
Yeah.
Or maybe even more. Yeah, maybe even more. So anyways, they think 4 in 5 adults, 80% of adults have a mobile phone. Okay? Do you understand, or are you confused?
The 5 is the 8, right?
4 and 5.
The 5 is 8.
No, you see, it's an English thing, I'm sorry. If I say 80% of people have a phone,
Yeah.
you can say that in English as 4 in 5 have a phone. It's the same meaning.
Okay.
Yes, sorry, 80% equals 4 in 5. Is okay?
Yeah.
Are you sure?
Yes,
Okay. So, what is the probability that in a group of 7 people, at least 3 of them have a phone? So in a group of 7, at least 3 have a phone. And they want your answer to 3 significant figures. The answer. That's what I said. That's what I said here. The 1, 2, 3 for the answer. Okay. We'll finish by doing this. Let's see if you can get full marks here. Because 4 marks is a lot. That's a lot for this. So let's see if you can get 4 marks.
0, 1, 2.
Yeah. Not so bad, right?
So if you can increase the size.
Yeah. Can you see?
Yeah.
Oh, Tom, you probably need some numbers here, don't you? 7C0 is 1, 7C1 is 7, and then 7C2 is 21.
Okay.
could probably do this on your calculator in one step.
This is 1 mark and calculate 2 marks and 3 significant figures.
Yeah, maybe it's like 1, 2, 1, yeah. See, no problem.
Just in part A. If this is in part B, it will be more hard.
Maybe we'll look at part B next time.
If the number like this, we use 5.
No, use 1, 2, 8 because you don't count the zeros. Do you know what I mean? You only count from here. Like, if I say 0.000123 3 SF means 0.000123. You don't count the zeros. You go 1, 2, 3.
Oh.
Yeah. Yeah, it's kind of very small, Tom. I don't know.
Maybe 7.
Got an answer?
Yes,
Too small?
no.
No. And 1 minus, yeah.
It's 7.
Yeah, this is not quite right. What did you use? Get an answer, Anthony.
Yeah, I've got an answer, but I've the wrong one. I made a mistake.
What was the mistake?
For instead of using n minus 0 for the second one, I was meant to do, so that would be 7 minus 2.
Yeah.
I put n, I just put 7.
Okay, instead of 7 minus 2. Okay. Did you get an answer now? Or are you fixing it?
I'm going.
You're going to, okay. Got an answer, Tom?
Yeah.
What you get?
To be maybe
No, it should be big.
0.
Yeah.
9
Close. I have the answer here. The answer is 0.995.
Okay.
That's close. You got 0.992?
1.
Oh, 991.
991.
99.
2.
Yeah, so 992. Yeah, but the actual answer is 995.
Okay.
So I think you made a small mistake. Oh, no, you didn't. The problem is your calculator.
But I think the calculator is the same. Why?
Yeah, but do you write all the numbers down, or just for some of the numbers?
Some of the numbers.
That's why. You see, because when we use this calculator,
You put all
we put everything, and this is the most accurate answer.
Okay.
Whereas when you do this,
Mm.
each time you have a small error,
Oh.
you know. So yeah, 992 is fine. 992 is fine. Good. So you know that's good. That's 4 marks.
Can I see the question?
The question.
Yeah.
Yeah. Yeah.
Mhm.
Okay. So if I can just zoom in to show you the marks here. Okay, so 1 minus 0, 1, 2. That gets you 1 mark. If you just write that, that's 1 mark. Okay?
Oh,
You-
okay.
yeah. If you do this calculation,
Just put them.
just write this down. This gives you 2 marks. And then if you calculate the right answer at the end, that's 1 mark. So for example, because your one has a small mistake,
Mhm.
you would still get 3 marks
Okay.
out of 4. You know, it's good. So, you know, the maths exam isn't so bad. It's not so bad. Yeah. Okay, so we were doing algebra last week, but maybe next week will we do some exam probability questions?
Yeah.
So you probably want to do more binomials, and then also this one here. He knows this one. You were doing this in class?
Yeah.
Yeah. You want to do it's called normal. We'll do some of this next week's exam questions, I think. Do you not go to class, Tom?
Go to class.
You go to class?
I go to class.
All the classes?
Nowadays, yeah.
Nowadays, yeah, okay. Right. We'll finish there, okay?